Hi, this is an instructional video on how to use the Prizmatix-LED Spectrum Viewer. We'll start off on the Prizmatix website on the microscopy page. We'll scroll down a little bit and we can see right here we have the LED Spectrum Viewers. We go in, as you can see we have several types of Spectrum Viewers. We're going to do our demonstration on the double LED Spectrum Viewer, but the design principle is basically the same for all systems. We'll start with a small overview of the page. As you can see, we have right here on the top we have an input data graph. It's a power versus wavelength graph. We have the LEDs that are designed in the system, and we have the dichroic mirror. If there are any filters in the system, they'll appear here as well. We'll scroll down a little bit. Right here we have a system diagram. You can see LED A, LED B, excitation filters A and B, and the dichroic mirror, and the output direction. It's important to notice LED B is always with the shorter wavelength. Now, right here on the left we have the area where we choose our LEDs: LED A, filters, LED B, the dichroics. Right here, a little under there, we have where we can pick our fluorophores. As you can see, they're color coded to the LEDs. And again, LED B is with the shorter wavelength. It'll be clear when we design the system in a minute. And right here on the bottom, we have the output data with the fluorophores, excitation, and emission, so we can design the system in a very, very good way. We'll scroll right back up here and we'll start designing a system. We'll begin by choosing our fluorophores. We have fluorophores A and B. As we said, I'm going to use DAPI and GFP, and fluorophore B is the lower wavelength corresponding to LED B, so we'll pick the DAPI for this one and the GFP for fluorophore A. Now we'll put on the excitation and emission bands. They're color coded, but you can change the color if you like. I like the basic ones, actually pretty easy to use. We have the excitation band and the emission bands for this, and you can see there's a small overlap here that we'll want to eliminate in a minute. We'll start by choosing our LED. How do we do that? We'll check out where there's a lot of power. Okay. That corresponds to the excitation bands. This whole area, as you can see, between 460 and 490 is a good choice for an LED because it covers a lot of ground here. So we go up here, we click on LED A, and right here you can choose which product family you want. We're going to stick with mic LEDs for now, and scroll down here a little bit. You can see part number, a peak wavelength, and a full width at half maximum, and of course how much power this puts out. We scroll down a little bit, we can see 465 CA. The peak is at 465, which is right smack in the middle of the excitation band, and a full width at half maximum of 29, which means it goes 50 nanometers to each side of the 465, so it's between 450 and 480, and it's pretty powerful, so this would actually be a good fit. Return to full view. We'll scroll back down here. We can see that envelops a lot of the excitation bands. Now we will want to apply filters, so there's a smaller overlap area. Okay, so I'll pick a filter right here. We click on the filter. Again, filter families, and again you have two numbers here. This one is the center wavelength, and this one is how wide the filter is. Again, 20 half and half. So for us, I think this would be a good filter from 485 to 435 nanometers. I click on return to full view. You can see the filter appears on the input data graph and it cuts off right here. We'll scroll down and we can see this has now been filtered and there's a smaller overlap area. Now I've prepared ahead the LED B and filter B, so I'll just pick them. And it's this one. Okay, see the filter appears here. I'll scroll down. You can see that has been filtered as well. We'll put on the excitation and emissions bands for DAPI, and you can see we're in the excitation band and there's nothing with the green LED on the emission band. That's good for us. Now the last thing we actually need to choose is our dichroic. We need something between these two that will not interfere with any of them. So somewhere around 420 should be good, as you can see right here. We'll scroll here, and 425 LPXR, probably a good choice. Again, product families, but this one is already a good choice for us. I'll click return to full view, and you can see the dichroic appears here, and it's again very good for us. Now we'll do a short overview of the system that we have. We have LED-A in the middle of the excitation band, almost no overlap with the emission band. That's good for us. We have LED-B in the middle of the excitation band of the fluorophore, almost no overlap, and we have a good mirror right here. Seems like a good system. Now if you want someone to review your system, you want to suggest a system, or you want to ask us, for instance, if that system is good, you can always click here, share this page. That puts up a nice little link to the system you designed. Control A, Control C, and that copies into the clipboard. You can paste it in an email or anything of that sort and send it to someone. I hope that was helpful, and have a good day.